Hey everyone. Today, we're going to demystify something that's super important, but let's be honest, can look pretty complex. The architecture of 5G roaming. So, let's just jump right in. You know that feeling, right? You're traveling, maybe on vacation, you pull out your phone and it just works. But have you ever actually stopped and wondered what's going on under the hood? How does your phone connect to a totally different network in another country and get data securely? Well, that's exactly what we're going to unpack today. Okay, so this is it, the official 3GPP architecture for 5G roaming. And yeah, at first glance, it looks like a total mess of acronyms and lines. It's a little intimidating. But I promise you, by the end of this short explainer, you're going to be able to look at this and see a clear, simple story, not just a confusing chart. All right, so think of me as your tour guide for this thing. First up, we just need to get our bearings and understand the basic layout of our map here. The very first thing you need to notice is that this whole diagram is split right down the middle. On the left, you've got the VPLMN, which stands for the Visited Public Land Mobile Network. That's just the fancy term for the local network you're connecting to when you travel. And on the right, you have the HPLMN, your home network. That's your carrier back home, the one that has your account and knows everything about your subscription. To keep this simple, we're going to break this whole thing down into just 3 core ideas. First, those 2 networks we just talked about. Second, we're going to trace what I call the data highway. That's the actual path your internet data takes. And finally, we'll head up to the control tower, the brains of the whole operation that makes all the decisions. All right, first stop on our tour, the data highway. This is probably the part that matters most to you as a user, right? It's all about getting your data to and from the internet as fast as humanly possible. And the key concept here is something called local breakout. Now, this is really cool. Instead of taking all your internet traffic and routing it all the way back to your home country before it hits the internet, local breakout lets your data break out directly from the network you're visiting. Trust me, this is a total game changer for speed and latency. So what's that path actually look like? Well, it starts with your device, the UE connecting to a local cell tower. From there, a component called the AMF manages your access. Then the SMF steps in to create your data session. And here's the crucial part. The data flows through something called the UPF, which acts like an on-ramp, putting your data directly onto the local internet. It's that simple. And here's the perfect way to think about it. Imagine you're in Japan, watching a video on your phone. With local breakout, that video is streaming from a server right there in Japan. Makes sense, right? Without it, the data would have to go from Japan all the way back to, say, the US, hit your home network, and then travel all the way back to your phone in Japan. The lag would be insane. Okay, so we've got the data highway sorted. Now let's look up in our diagram to what I'm calling the control tower. This is where all the thinking happens, all the logic, the rules, and the decision-making. Honestly, the best way to get your head around the 5G control plane is to think of the 5G core as a city of microservices. It's not one giant clunky thing. Instead, it's a bunch of small, specialized, independent services that are all talking to each other to get things done. This city is built on something called a service-based architecture, or SBA. You see that blue line running across the top of the diagram? You can basically think of that as a communication bus. All these different network functions are just using modern APIs to talk to each other over that bus. It's a lot like how modern apps and websites work in the cloud, and it makes the whole system incredibly flexible. And in our little microservice city, you've got a few key players. The AMF is like the front desk, managing who gets in. The SMF is the traffic controller for your data. The PCF is the rulebook, deciding your data speeds and so on. The UDM is the city's records office, holding your profile. The AUSF is the security guard, checking your ID. And the NRF, that's the city's yellow pages, helping all these services find each other. So that brings up a big question. How do these 2 completely separate networks from 2 different companies talk to each other safely and securely? Let's take a look at the border crossing, the gateway between them. Well, that's where this thing comes in, this SEP-P. You can just think of it as a super secure bouncer at the border between the 2 networks. It's an API gateway and a firewall, all rolled into one, and it's the only point of contact between these 2 operators. So this component, the SEP, Security Edge Protection Proxy, is absolutely critical. You'll see one on the visited side, the VSEP, and one on the home side, the HSEP. Its one and only job is to handle all the important control messages crossing that border. It keeps the connection secure, it filters what gets through, and it even hides the internal details of one network from the other. It's kind of like a digital diplomat. All right, we've seen the highway, we've visited the control tower, and we've met the Border Patrol. Let's put the whole story together now, from the moment you turn on your phone.
Here's how it all happens, step by step. 1. Your phone connects to the local visited network. 2. That network immediately contacts your home network through that secure SEPP gateway to check who you are. 3. Your home network's UDM looks you up, confirms you're a paying customer, and sends your profile back. 4. Now that you're authorized, the visited network sets up that local data highway for you. And 5. Your data breaks out directly onto the local internet. And boom, you get a fast, low-latency connection.
And look at that, we're right back where we started. But this time, it shouldn't look so crazy, right? It's not just some complex chart anymore. Now you can actually see the story. You see the data highway down at the bottom, the control tower of microservices up top, and that secure SEP border right in the middle. So if you walk away remembering just 3 things today, make it these. First, we have the data highway for super fast local internet access. Second, we have the control tower, which is like a flexible city of microservices making all the decisions. And third, we have the secure border, that trusted gateway between the 2 different operators. And all of this leaves us with a pretty cool, kind of mind-bending question. This whole architecture is quickly moving from being built on physical boxes to being pure software that can run in any cloud. So as these networks become completely virtual, what does location even really mean anymore? Something to chew on. Thanks so much for tuning in.